Hello and welcome to the session. In this session, we are going to discuss about normal distribution. Normal distribution is a continuous distribution whose curve is bell-shaped and symmetrical. The curve of normal distribution is called normal curve. The graph here shows the curve of normal distribution. This curve of normal distribution is bell-shaped and also symmetrical. The curve shows that the frequencies in the normal distribution are concentrated at the center of the distribution. It is also called Gaussian distribution. Let us now discuss the properties of normal distribution. In a normal distribution, the mean is equal to the median is equal to the mode. The normal curve is bell-shaped. Also, the normal curve is symmetrical about the mean. The total area under normal curve is equal to 1. The normal curve approaches x-axis but it never touches x-axis as it moves away from mean. Let us now see what are the parameters of normal distribution. The shape of a normal curve and its position on the x-axis will depend on its mean and standard deviation. It means the curve for different variables that are normally distributed will have similar bell shape, but they will have different position and spread. For example, see the two normal curves given. We can see here that curve A is shorter and wider than curve B. This is because curve A has a bigger standard deviation than curve B and a wider spread. Thus, normal distribution has parameters mean, mu and variance sigma square, and we can write a random variable x follows normal distribution with mean mu and variance sigma square. the curve of normal distribution for random variable x with parameters mu and sigma square, that is mean mu and variance sigma square, with x lying between minus infinity and infinity, is described by the function fx is equal to 1 upon sigma root 2 pi into e raised to power minus of x minus mu whole square upon 2 sigma square for all real values of x. Let us now discuss the area under the normal curve. To draw a normal curve, we take the horizontal axis. Now, the points taken on the horizontal axis represent the value that a certain number of standard deviations from the mean. The central value is taken as mean, denoted by mu. The values greater than mean, that is on the right side of the mean, are taken as mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, and so on. Since the curve is symmetric, therefore the values on the left side of the mean are taken as mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, and so on. The total area under the curve about the x-axis is 1. It also represents the total probability of distribution. Let us now discuss the distribution of area. Mean divides the graph into two equal parts. 50% of the values are on the right side of the mean and 50% of the values are on the left side of the mean. About 68% of the data or area lies between mu minus sigma and mu plus sigma. About 95% of the area lies between mu minus 2 sigma and mu plus 2 sigma, and about 99.7% of the data or area lies between mu minus 3 sigma and mu plus 3 sigma. Note that since the curve is symmetrical about mean, so the area for values greater than mean is equal to the areas for values less than mean. It means if 68% of the data or area lies between mu minus sigma and mu plus sigma, so 34% of the area will lie between mu and mu minus sigma, and 34% of the area will lie between mu and mu plus sigma. So in this session we have discussed about normal distribution and its properties, parameters, area under the normal curve, and its distribution. This completes our session. Hope you enjoyed the session.